Okay, welcome to the fourth lesson in the atomic structure topic. Today we are focusing on filtration and crystallization, and this is the second lesson in the series of lessons looking at separation techniques. So we've looked back at elements, compounds and mixtures, and how we can have a mixture of a few different things, and actually the mixtures can be separated. Last time we looked at chromatography, so maybe worth a bit of a recap. So a recap question at the beginning. This is our chromatography paper. We would put it in water and we would draw a line along the bottom. Now, why do we have to make that line in pencil and not pen? Let's have a quick think. And the answer is that we want our line to stay fixed. We don't want it to move up, because if we put water in and the water starts to soak up, we don't want our, if it was pen, we don't want that pen to get soaked up through the paper as well, which is why we use pencil, because pencil is insoluble in water. So as the solvent moves up, it gets to a point at the top, and we call that the solvent front. Okay, and if we had some kind of food dye or food colouring at the bottom, that would also move up, but it might separate into different colours as it was going up the paper. And all of those would have their own RF value. So can you remember the equation to work out the RF value? So each of these moves their own distance. So let's say for that red, we would look at the distance travelled by the red divided by the distance travelled by the solvent front, and that would be our RF value. Okay, that's a bit of recap over last lesson. So today we're looking specifically at filtration and crystallization, some pretty long sciencey words just there. Again, purple keyword straight away, filtration. It's relying on us understanding that we have some other processes that we're going to link in as well. So understanding that we have things like the term evaporation as well. So we're going to describe the stages involved in filtration and evaporation. We're going to explain how crystallization is used to separate soluble, that's one from last time, salts from a solution. Lots of sol words again today. And we're going to describe the conditions necessary to produce different sized crystals. Okay, first task, a word hunt. As I said before, these slides, this lesson has been adapted from lots of the free Twinkle resources that have come out. So thanks for this wonderful task from them. So can you find as many words as possible? I'm just having a little look, and there's quite a few words that I can see. We can spell salt going up from the bottom right. If I use that S, and then there's an A a couple above it, and an L just below it, and a T up on the right hand side, so I could have the word salt in there. So an extra challenge to this is, can you find the word that uses all of those letters? Crumbs, there are 15 letters. That is a very long word. Little hint, the word was on the previous slide. So pause the video and have a go. Okay, like I said, I think I could see the word salt. There's lots of non-sciencey words in there as well. Sat. Ooh, roll. Oh yeah, it's making me hungry. At. Love a two-letter word. You feel like you should be able to get science, but you can't. And then, I'm sure there are some very long words in there as well. Okay, so the big long word on the previous side was crystallization, and we're going to look at that in greater depth later. So, second task, this is getting us to think about separating a substance. So, rock salt is a mixture of salt and sand. It is spread on roads in winter to prevent ice from forming. So how could we separate the salt and the sand? Can you think of how you would do it using any of the equipment below? Then write a method using the diagrams on the following slide. So the following slide has got 6 diagrams on it. I've said this before, a method is quite often 6 marks. Okay, so it would be worth getting as much detail in as you can and using the equipment. So you've got rock salt, filter paper, a funnel, a mortar and a pestle, or is it a pestle and a mortar? Who knows? Stirring rod, a beaker, water, the Bunsen burner, and an evaporating dish. If you've ever wondered why a Bunsen burner gets a capital B, it's because it's named after someone. That's their surname, Mr. or Mrs. Bunsen. So, our method then. So, first of all, I'm just going to put like 1 or 2 little words in each one. So step 1, you've got to crush your rock salt down. Okay. Second one, you're going to want to add water. And the reason we're adding water is to dissolve the salt. So you'll have the salt dissolved in the water, but the solid sand that was mentioned on the previous slide will still be in the water, and so you can easily use filtration to separate those out. You're exploiting the difference in properties between a solid and a liquid. The liquid will travel through the filter paper, but the solid will not. So you are left with this stuff down at the bottom, which we call our filtrate. Is that going to fit? Oh, I'm going onto the dark purple with a dark pen. Never mind. And our filtrate, we're going to put in an evaporating dish. So I'm going to put that down here. So evaporating dish, or evaporating basin it sometimes gets called. And essentially that is a nice wide, fairly flat dish that allows things to cool quite quickly, a little bit like a shallow soup bowl. Nice and wide, large surface area to allow for evaporation. We might add some heat using our Bunsen burner, and we're going to be left with crystals. Okay, so our crystallisation that was mentioned at the beginning. Oh, he's going off the slide again. Terrible. So yeah, 6 points, 6 things that we are looking at, and we're going to get crystals just there. Okay, the size of the crystals is going to depend on how quickly or slowly the water is evaporated. The faster the water is evaporated, the smaller the crystals. The longer you leave it and the slower the evaporation, the larger the crystals that will form. So here's an example of a slower way of doing it, which is going to give you much larger crystals like those ones down there. So gently heat the solution in an evaporating dish. As soon as the crystals start to form, then you take the heat away from underneath and you just leave the solution to cool. The crystals are going to become insoluble in the cold, and they can be filtered off from the solution. Okay, so that will give you some nice big crystals. So, next task, filtration and crystallisation. This is an exam style question. Our nice little scientist holding a round bottom flask and a big boiling tube just there. Can you describe how insoluble calcium carbonate and soluble ammonium carbonate could be separated from water? Now, I'm going to say this. This is where students always get confused. As soon as you start putting in words, so word equations, or a compound using words, people immediately think, oh, I haven't been taught calcium carbonate. Oh, I don't know what ammonium carbonate is. It doesn't matter, okay? They've not, in this question, asked you about that, okay? They've given you the information that you need, okay? Because they've told you that one is insoluble, so it's a solid, and one is soluble, so it must be in solution with the water. Okay, so a little bit like our sand and salt water that we were filtering off earlier. The second question, a pupil has separated 65.5 grams of calcium carbonate and ammonium carbonate. However, after separating them, the mass of the calcium carbonate was 30 grams and the mass of the ammonium carbonate was 40 grams. what is a possible reason for this difference in mass? Okay, because 30 and 40 would add up to 70, so there's obviously something going on here. So have a little think about the answers to the questions, pause the video, see what you come up with, and then move on to the answers. So here we go. The ammonium carbonate will dissolve in water. We know that because it says it is soluble. The insoluble calcium carbonate can be filtered and will remain on the filter paper. It's a solid, it won't go through the little holes on the filter paper. To obtain the ammonium carbonate, pour the solution into an evaporating dish and heat. Just like our big method earlier, the ammonium carbonate crystals are going to appear when the water evaporates. Okay. Quite often, people kind of miss that final step. They sort of talk about the filtering and they forget to mention then getting the crystals out at the end. The second question, why was there a difference? It will be very difficult to completely dry the chemicals, so therefore the excess water is what has increased the mass. 30 and 40 add up to a total of 70 grams. Now, I used to work in industry. I used to make chemicals all the time. I used to make lots of polymers, and the structure of those, with lots of the compounds all folded over itself, would quite easily trap water as part of the substance. And therefore, when you were weighing out your polymer, what you thought was pure polymer at the end, you actually had water trapped in between. So if I show you over here, and I've got lots of polymer strands, actually held in between those strands might still be some H2O, some water, and it's very difficult to get rid of all the water in between all of these little chemicals. So it has to be heated for a really long time at quite a low heat, because you don't want to destroy your chemical. Let's say you've made ibuprofen or paracetamol. You don't want to raise that to a really high temperature, because that ibuprofen might break down and be broken down into smaller different chemicals when you were just trying to get rid of water. So we have to dry things for a long time at a low heat to try and drive off all of the water, and then we know that the mass that we've got should just be our product. So task 4, this is optional because it's making something at home. Find yourself a method, if you can, on the internet to make some sugar crystals at home. You'll need some kind of sugar solution and a way, they've shown just here, a way to hang some string, soaking the string up in the sugar solution and wait for the water to evaporate to see if you can get some crystals. If you've got any kind of food colouring, that will help you to make different coloured crystals as well. So down at the bottom, some suggested equipment: plastic cup, water, sugar, a teaspoon, pencil, and a piece of cotton, some kind of fibre that can soak up the solution. So there we go. That's a nice little optional practical if you've got time and the equipment. And we've reached the end of another lesson, a whistle-stop tour that was, through filtration and crystallisation. Any separation technique is relying on the fact that you can separate things because of a difference in property. Okay, I could separate iron from sulfur, for example, because iron is magnetic and the sulfur isn't. I could have this really horrendous mix of yellow sulfur and little iron filings, and I'm not going to separate that with filter paper. And so I could easily just get a magnet and get all of the iron out because it's magnetic, and it would leave the sulfur behind. So filtration and crystallization are relying on a difference in properties of things. So again, maybe come up with a bullet point list of the key points. You could briefly summarize all of your key points onto a tiny little post-it note, or you could write some detailed notes on little flashcards, learn them, memorize them. There's some great apps and things online where you can make flashcards. Quizlet is very good, especially because people have already made lots and lots of them already, so you can just find things that people have already made. And go and test yourself as well. If you've got an account on Seneca, or you could set some Kahoot quizzes for friends, or go and find them on there. All these things are really going to help. Okay, that's the end.